I did all the math right, but I guess I'm not good with the actual, like, terminology of it, I guess. Let me get to it real quick. Yeah, in lesson 11, in the homework quiz, in question 14, it was asking about, suppose the alternative hypothesis of this test have been lower-tailed instead of two-tailed. How would this affect the conclusions of this test? I honestly don't understand. I don't know why. What a two-tailed graph is, what a one-tailed graph is, what a lower-tailed graph is. What does that all mean?
So from what I understand, it's kind of like applies to the like the normal probability applet. So let me share my screen with you and then I can point it out. Okay. But so like this would be a two-tailed null hypothesis or whatever, because you're using both the top and the bottom.
Okay.
So the question asked, number 14, is that what you said? Had been lower-tailed instead of two-tailed. So what I got for that was that the conclusion would be the same as a two-tailed test, although the p-value for the lower two-tailed test is different. It is still less than alpha, because it's just gonna make your overall thing smaller because you're just taking half of it instead of both sides. So it's like if you were to say for your hypothesis, let's say you're measuring like, I predict that, I don't know, does it give you an example? So for this it's saying they're comparing the translation data. So they want to know if the mean score is going to be larger or smaller than the population mean score, which is 0.295. But if you were just doing a lower tail, then you would just do, I just want to know how much of the population is lower than 0.295 instead of lower and higher.
Okay.
Does that make sense?
Okay, so then why would it be smaller than alpha? What does that mean? Oh, because the probability was smaller than alpha? Is that why?
Yeah, so the probability was already small. So then if you only take half of it, it's still going to be small.
Okay. Then why is it, let me look at it. The conclusion would be the same as a two-tailed test. Then why would the conclusion be the same? Is it because it's, and why is that then? I'm trying to understand.
Okay, so I think, so the alpha level is 0.05, and we got that the p-value is 0.006. So that's like way lower than the alpha value. So because the p-value is so small that if you took all of the data above and below, or if you just took what was below, that is still going to be really small. So it's still going to be way smaller than 0.05.
Okay. Okay.
At least that's how I understand it.
Yeah, that makes sense. Okay.
Okay. Should we get started on the quiz?
I think so.
Yeah, let's do it. I feel like the two chapters we did this time were almost the exact same. Like, I didn't feel like there was that much that was different between the two.
Yeah, I feel like they could have put it into one.
Yeah.
I got so confused with the whole SPSS program
Oh
because
yeah.
I thought that we were supposed to have that. And so the teacher told me that we didn't. So we're just using the Excel program.
Mm-hmm.
Oh yeah.
Is it the quantitative inference
That's the
one?
one that I used.
Yeah.
Now, what part of it do we use, though? That's what I'm trying to make sure I know.
So it depends on the problem that you're doing. I think on the first, on number, I think it was 12,
Mm-hmm.
I think we used more of the one sample t-test. Oh, just kidding. No, we used the paired sample t-test for the first one and then the two sample t-test for chapter 13.
Yeah, I think so too.
Okay. So we should start.
Okay.
Okay.
Do you guys know if the t-distribution applet is different than the normal probability applet, or is that all the same?
I think the T distribution one just has an option to put the degrees of freedom in it.
Okay.
Right.
Okay. Um,
Okay, there's a lot to open.
yeah.
Lots of stuff.
Okay, I'm ready.
Okay.
Okay, I'm just about there.
Okay.
Okay. Okay, I'm good.
All right.
All right.
I'll start. Suppose we have a set of paired data and let D equal X after minus X before. The null hypothesis is H not equal, well, the null hypothesis is 0. The alternative hypothesis, it does not equal 0. And the population standard deviation is not known. Jordan collects a sample size of n equals 9 and computes D equals 2.2 and the standard deviation is 3.3. What is the value of the test statistic?
Okay. So the test statistic, in order to find that, we take the population or the sample mean divided by, do we have the sample mean?
Is that supposed to be the D with the
Is it
bar
D?
over it?
I think that's what it is.
Hmm.
Yeah, that's the sample mean.
Okay. So we take that minus the population mean, which is 0. Is that right? Divided by the standard deviation, the square root of the standard deviation divided by the population number.
Wait, so it's the standard deviation divided by the square root of the population number.
Oh yes.
Wait, say
Isn't
that one more
that
time,
just-
Julia.
Oh, sorry. Go ahead. Sorry.
Go for it.
Well, I was just thinking like it's right? So it's 2.2 minus 0, right?
Mm-hmm.
So it's basically the t-score, isn't it?
I think so.
So divided by 3.3 divided by
the square root of 9.
Yeah.
So I'll just put 2.2 divided by 2.3 divided by the square root of 9. I got 2.
I did too.
Mm-hmm. 2.2?
Yeah,
So it's just 2, right?
that's what I got.
Oh, okay.
Okay. Question 4. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. So are we putting that in the probability applet?
I'm not really sure.
How do we find the p-value? For some reason,
Yeah, that's what's confusing me is usually like the probability of something happening is the p-value.
Right.
So I'm not really sure.
degrees of freedom. Oh, yeah, you put the test statistic in the well, this is what's in the textbook in the applet. And I think that's what shows you the p-value.
So just put in 2?
I guess so.
That gives me 0.0403.
Wait, in the t probability applet?
Yeah, I put in 2 for the t-value, and then I put in 8 for the degrees of freedom. And then I got the same probability that they got.
Why did you put 8?
Because degrees of freedom is 1 minus the sample size.
You're right. Okay.
But then I don't really know where to go from there.
Let me look.
Because would the p-value just be 0.040?
I think so. It's just weird that they gave us it.
Yeah.
I don't know, let's go for it.
Okay. If we get
How
it
did
wrong,
you
we
get
can always try.
0.040? I did not get that.
So you have to only do the rightmost side because you want it to be only larger than that.
Oh, the right side?
Yeah. Test statistic greater than Jordan's test. Value for Jordan's hypothesis.
I guess. If I'm wrong, I am very, very sorry.
Who knows? I'm just wondering if we're supposed to highlight like a different part of it because it says that the probability of obtaining a test statistic greater than hers is that. So I'm wondering if we're supposed to highlight the rest of it and get like.
Wait, for the hypothesis test, it says
Not equal.
Is that it's not equal, so maybe it should be
I think it's both.
and lower, right?
Yeah.
Then that would be equal to 1 though, wouldn't it? Or would it be like just the not including the middle?
Not including the middle. Yeah.
It'd
So
be
just
higher and lower. Right.
So get like 0.081.
Yeah.
Yeah.
Okay.
Let's try that. Because it just seems too easy for them to get that too.
Yeah, I agree.
Okay. That makes sense.
Okay, I can do the next one.
Mhm.
Use the data file chapter 12 data A1 to answer the next 6 questions. Perform a paired samples t-test in SPSS. Be sure that the test is not group 1 minus group 2. Be sure that the test group does group 1 minus group 2. Use the null hypothesis. The mean is equal to 0, and the alternative hypothesis, mean is not equal to 0, and a level of significance of A equals 0.0 or 0.10. What is the test statistic?
Oh, okay. So it's data A.
And this one is the paired sample one,
So
right?
yes. So we're just basically copy and pasting, right?
Yeah. Just make sure that you put in group 1 first.
Okay. T. So not equal to. Is the confidence level, are we just keeping that at 0.95?
They haven't told us to do anything else, so I would probably say yes.
Okay. I got 0.407.
I got the same.
Okay. 07.
I copied something weird. What just happened?
Okay. Question 6, what is the p-value?
I got 0.689.
Sorry, 1 second. Mine
Okay.
went down and it didn't give me anything. Let's try opening this again. Why did it do that? So I'm gonna screen share real quick because I don't know why this is doing this.
Okay.
So I put in the data in the first column and then the second one, and then in the differences, it just showed up already. And then when I tried to delete it, it like gave me an error.
Yeah, so I think it has the equations already in there, so the differences should show up. but when you delete it, then it'll delete the equations as well. But you can just put equals like A5
A5
or whatever it
minus
is
B5.
minus B5.
Which one? Just not that one. Sorry.
Or you can just click on the cells.
Oh, and I just have to do
drag
that.
that all the way down.
And I think like you click on that thing or 2.1 and I think you just like copy it and just drag it all the way down.
Or you can like double click on the
There we
left
There you go.
corner or right corner.
There you go.
Gotcha.
It's working.
Right. Okay. Okay. Okay, sorry, keep going.
It's okay. The p-value. Oh, did you catch up?
Yeah.
Okay. So the p-value, I got 0.689.
I got the same.
Okay.
Yep.
And then fail to reject the null hypothesis.
Mm-hmm.
Okay. Suppose your alternative hypothesis instead is that the mean is greater than 0. What is the correct decision based on this evidence? So we have to change that little drop-down menu.
Yeah. Is that? Oh, never mind.
It's still greater than the
And the
Yeah.
alpha.
Or then the alpha, yeah, sorry.
But I think it would be we have insufficient evidence that the mean of the differences is greater than 0. Is that right? Because we're not going to reject the null hypothesis.
Right. Well, it's higher. No, it's higher though. Wait. Fail to reject. Oh no, you're right. Okay. You're right. I think that's what it is.
Okay.
Just trying to get through. Are you guys on the chapter 12 data B?
Yeah.
Okay. Is it equal to? Okay.
So for that first one, question 9, which is greater sample size or degrees of freedom, wouldn't it be the sample size?
It's always like one greater, isn't it?
Yeah.
Yeah.
Okay.
So it's reject the null, right?
Yes.
Oh yeah,
For
wait, I skipped that. Sorry.
number 10, the p-value, did you get 0.0014?
I got
Oh, wait.
0.00 1 2.
One.
I got the
Yeah.
same thing. Sorry, I just forgot to change the degrees of freedom. So just 0.001?
Yeah.
For two decimal places? Okay. Sweet.
And then we reject.
Mm-hmm.
Yeah.
How are we doing?
Okay.
Well, time to do laundry again. I'm not done. I'm not done. Okay. You doing all right? My husband is taking care of the baby. Having a rough time.
That's cute.
Okay. All right. Question 12. Decide to try another alternate hypothesis. Greater than significance.
It decreases, right?
Decreased. Oh, decreased.
Looks like it decreased a lot.
Yeah. And then you reject that one as well, right?
Yeah. Yeah. He's happy though. Okay. Based on your response from the previous question, what conclusion do you make? I really don't understand like how to determine the answer to this question. So the p-value was less than the level of significance, but what does that even mean? Like,
so the level of significance is basically telling you that you know up to about like a 5% chance that, or like up to 95% chance that that is not true.
so that the null hypothesis isn't?
Yeah. So like if it's if it's like 0.05, it's telling you that there's only 5% that could, if it's under that, there's only 5% that could be wrong. That it could be like a error. I can't remember which error it is.
Wait, there's only a 5% chance that
you could have like an error in your
the
data.
Alternative is true?
That the null hypothesis is true if you have it underneath 5. But if it's above 5, then it means that a lot of your data is similar enough that it isn't sufficient.
Oh, that the alternative is true.
That the null hypothesis is true. So if you have a higher p-value, then it means that the null hypothesis is that you don't reject it. Not necessarily that it's true, but just that you don't reject it.
Oh, okay.
But if you have a really low one, then you do reject it. So then for this question, if you're going to reject the null hypothesis, then you have sufficient evidence that that hypothesis is wrong. But so it would be either A or C. But because you're measuring the difference, I think it's going to be C. Because
There is a main difference between the two groups.
Because the hypothesis was saying that the null hypothesis was saying that they were equal, and the alternate hypothesis was saying that they weren't. So if you reject the null hypothesis, then you accept the alternate.
Gotcha.
So if it's failed to reject, it's insufficient evidence then.
If yes.
Okay.
Okay. As we've seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest value?
I found that I think it's. I thought it was greater than, or at least that's what I've seen, but I don't know.
I think greater than and less than would end up being the same. Because if you're just taking the top half or the bottom half, it's going to be
a small value.
Yeah. Because since it's that curve, both sides are the same. So wherever you're at, if you take the smaller half, it's going to be equal to the higher half.
Okay.
But I don't really know because I don't like putting not enough information. Depends on the problem. But I know it's not A. But I think that B and D are the same. So not enough information?
We'll check.
For that one.
We'll check on that one.
Okay. Sounds good. Goodness. Okay, determine the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2. Input your answers below. Question 16, what is the point estimate for this 95% confidence interval?
What is the point estimate again?
You know, I'm
It's
not.
Just mean, isn't it?
I have no idea.
Wait, no, point estimate.
I think you're right. I think it is the mean. Go up. Where is the?
Oh, I think. Yeah, that's confusing because point estimators are mean, standard deviation, and variance.
Point estimators.
Yeah, it could be. Oh,
What the heck? You've learned.
Oh wait, no, yeah, it says, but for the question, it says determine the 95% confidence interval for the mean difference.
Oh, yeah. Yes, you're right.
But which group, though?
Of all three of them? I don't know.
That's not
Would it
very...
be... Oh, goodness.
Jeez.
What is the point estimate for this 95% confidence interval?
Is that the mean?
So would it just be like the middle point in that confidence interval that it gives us? So like 5.3. Oh,
That's the lower part.
0.07. Yeah. So if you subtract those and then divide it by 2 and then add that to 5.303, you get 11.955.
That's the mean anyway on this.
Yeah, that's the mean of the differences. So I would guess that's the one we're looking for.
I'm just going to put that in.
Okay.
We're doing greater than, right?
I don't think it matters.
I don't think it matters because I put it back to not equal to and it's the same.
Yeah, I don't think it'll change the confidence interval.
Right. Okay. It just changes the p-value. Okay. Okay.
Okay. Question 17 was the margin of error for this 95% confidence interval.
3.199.
That's not
the-
what I got when I put it in my calculator, but
I thought margin of error, isn't that the upper bound minus the lower bound?
that's what I was doing. But is it the upper bound? Is it just the upper bound minus the lower bound, or is it the upper bound minus the lower bound divided by 2?
Oh, divided by 2. That's right.
Wait, I'm so confused. Wait, what?
So if you take the upper bound and the lower bound of the confidence interval,
Okay.
that gives you like kind of the range in between. So if you take upper bound, which is 18.607 minus the lower bound, which is 5.303, that'll give you the difference between the two. So then if you divide that in half, then that'll give you the distance from 1 to the mean, from like either the upper or lower confidence interval to the mean.
6.652?
That's what I got.
Is that an actual formula?
Yeah.
I think so.
What's that formula? I don't remember that formula. I thought the margin of error was like the 95% from the on the applet times the standard deviation divided by the square root of the sample. Unless this is different.
I think that's another way to do it. But this also gives you the margin of error, because I think the TA posted a thing, or the teacher posted a thing about that equation.
Oh, is that right? Okay.
I think so.
Yeah, I have no idea.
We'll see
Do you
when
remember?
Yeah.
Do you remember which chapter the margin of error was in?
It's lesson 10.
10.
Okay. Lesson 10.
That's what I'm looking at right now.
Okay.
You see.
Okay. I think Sister Withers, I think she posted or she sent us an email about it as well.
Mm-hmm.
Okay.
I'm getting all weird numbers. Oh my goodness.
Okay. Well, the next two questions are relatively easy because they're just upper and lower bound.
We'll figure it out when something turns down. Okay.
Yeah. We'll see if we get it right or not.
5.303
Yeah.
Yep.
and 18.607.
Yep. Okay, I'll turn it in and see what we get.
Okay.
This one I
Okay.
feel like we've had the most uncertainty in questions. Guys, we got 100%.
Dude, nice.
That makes
So-
me so happy.
What was 17 again?
I got 6.652.
6.652. And that is when you took the upper bound and the lower bound and you subtracted them and you
Yeah.
divided that by 2.
Mm-hmm.
Mhm.
Okay.
Guys, I definitely was not expecting 100% on that.
And we had a lot of questions
Wow.
that were like, oh, see.
Yeah, we'll see if we'll change it once we get the wrong answer.
Yay!
Goodness, that's so nice.
That's a relief.
Okay, on to 13. Okay.
All right, you ready?
Think so.
Okay.
All right, question 3. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply.
Is it the first 2?
Does it have to be a random sample?
I
Oh,
think it does have to be a simple random sample and normally distributed.
let me make sure. Preparation.
I think that was question in chapter 13. The maybe not. Sure, there's a question about that in our homework.
Yeah, you guys were right.
Okay.
So it is the first 2?
Mm-hmm.
Question 4.
Okay.
The test statistic for the hypothesis test comparing two means with independent samples is it's still a t-score, isn't it?
T-score, right?
I think so.
Is it?
I think it is. Because z-scores we haven't really used.
Z-scores
I
are,
don't think we
yeah, only for the one.
one sample.
Yeah.
And I don't think we've talked about F statistics. Okay.
Okay. Two samples are independent if knowing which subjects will be in group 1 determines which subjects will be in group 2, or knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2.
I think it's the
right?
first one.
I thought it was the second one.
I did too, because the first one is the dependent ones, like what we were doing in chapter 12.
Is it?
Yeah, it's like, what was the one example? It was like the weight loss. It was the before and after, because they relate to each other, but independent. They don't have to be
It'd be
from
like,
the same person.
yeah, it'd be like comparing men's wages with women's wages.
But it, oh yeah, it says dependent samples. Okay, I read that wrong. You're right. Okay. Okay. Okay.
Let's see.
For the next 6 questions, use the data file dentist office bills. This data represents a simple random sample of dentist bills at a dentist office in Idaho Falls and a dentist office in Rexburg. Let mean 1 be the mean bill of Idaho Falls office and let the mean 2 be the mean bill of the Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we have the null hypothesis the mean of 1 is equal to the mean of 2, and the alternate hypothesis mean of 1 is less than the mean of 2. Use level of significance of alpha equals 1.10. Question 6, what is the degrees of freedom? So in this one, we're putting the data into the 2 sample t-test, right?
I think so, yeah.
Okay.
Okay.
Okay, so the degrees of freedom that I'm getting is 37.996.
That's a weird number. Is it
Yeah.
supposed to be a whole number?
With the 2 sample t-test, they aren't typically.
Wait, how do you get the degrees of freedom?
It's just
on
there.
the chart. It says
Oh.
EF.
So, okay.
So then the standard deviation would be 206.637.
That's for variable 2, isn't it?
Yeah, isn't variable 2
Yeah,
the
that's
Rexburg?
Rexburg. Yeah.
Oh, Rexburg. Okay.
Okay. And then the test statistic, negative 0.434.
So it's a negative?
Yep.
What is the p-value?
That'd be 0.667.
Yeah, that's what I got.
Okay, quick question. Are we supposed to do above and below? Because the alternate hypothesis is just that mean 1 is less than mean 2.
Oh. So we gotta do less than.
I think so.
Oh, okay. So it'd be 0.333.
I got 334.
334?
Actually, 1 second. I didn't put the degrees of freedom in. So that might change it. Okay, I got 333.
Okay.
Okay, what is the correct decision?
Fail to reject.
Yeah, I think so.
Okay, suppose instead that you had used the alternative hypothesis that mean 1 does not equal mean 2. What is the correct decision based on this evidence?
Is it the first one?
I don't think so because we don't have sufficient evidence because we're failing to reject the null hypothesis.
Okay. So it's insufficient.
Yeah.
Okay.
And we're trying to compare if they're different instead of if they're the same. So I think it would be number 2.
Oh, so number 2. Okay. I always get those mixed up.
Okay. For the next 6 questions, use the data file freshman dinner. This data represents numbers of times freshman students from Utah and Colorado cook their own dinner in a month. Let mean 1 represent the number of times a month that students from Colorado cooks dinner, and let mean 2 represent the mean for Utah students. You suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is mean 1 is equal to mean 2. Use a level of significance of A equals 0.05. What is the appropriate alternative hypothesis?
Mean 1 does not equal mean 2?
Yeah, I think so.
Okay.
Okay. What is the test statistic? I'm getting negative 0.845.
You got a negative?
Yeah, I did too.
Did you put the Colorado variable first or the Utah?
Utah first.
I think it's supposed to be Colorado first.
Oh.
They were tricksy on that one.
They didn't specify?
They did. In the Excel file, they put the other one first.
Yeah,
so
they switched it. So in the explanation, it says, let mean 1 represent the mean times the Colorado student cooks.
Okay. Let me fix that real quick. Okay, now it's a negative.
Okay.
All right, and then the p-value is 0.410.
411. I got 411.
411, sorry.
Oh. Yeah. I got 410, but I might have done something wrong. I think I put the right degrees of freedom in. Yeah. I don't know what I did differently. You just put in negative 0.845, and then your degrees of freedom is 16.562.
Mm-hmm.
And the p-value, I mean, it's 0.410728036.
Yeah.
Yeah, I got 0.4102.
Huh.
So I don't know why that's different.
It's so close.
Yeah.
Odd.
Let me try again.
That's odd.
Yeah, I'm still getting the same thing.
So weird.
Strange.
You have 14 numbers for variable 1 and then 16 numbers for variable 2.
I have 10 for variable 1 and 12 for variable 2. So.
Oh, sorry. It goes to 16, my bad.
Yeah, for the first one it goes to 14, second one it goes to 16. Yeah, I don't know why this is so different. We can just put in 0.411, and then if it doesn't work, then we can try 0.410.
Okay.
Okay.
That sounds
good.
Okay, question 15. What decision do you make? Fail to reject the null hypothesis?
Yeah, because significance is, this one is 0.05.
Okay. So then determine 95% confidence interval for mean 1 minus mean 2, an estimate of the difference between mean 1 and mean 2. Input your answers below. So the margin of error for 95% confidence interval.
So are we doing that same thing where we do higher bound minus lower bound?
Mm-hmm.
Divided by 2.
-5.4. I got 3.6805.
I got the same.
3 point.
So 3.681.
I don't know because it doesn't say to round to 3. That's
Well,
on that one.
At the top, it says, when calculating anything, please remember to round to 3 decimal places unless otherwise specified.
Okay. Okay.
Wow.
And then just upper and lower bound. Did you guys get the lower bound is negative 5.147 and upper bound is 2.214?
Yes.
Yes, ma'am.
Okay, I'll submit it.
Okay.
Oh, dang it. Okay, 100%.
Nice
That is
job.
what I want to hear.
That is so nice.
What a relief.
All right. Good job, guys. I gotta go calm a screaming
Okay.
baby.
That's all
And
good?
my husband.
Cool.
All
We'll
right.
see
See you guys next week.
Bye.